Question 10 had 3 parts. Solve, I think it was x was the variable in each case, and you were encouraged to include a check for your solutions. So for A, I would begin by just subtracting 12. I don't think many of you had any problems with this. 4x would have to be negative 20 then, and if I divide both sides by 4, I can see that x would have to be negative 5. So that was the first answer, and I just asked that you write them down on this line. You all did that. The next problem was quite interesting, and here's the thing that I understand where it comes from, but it's a little frustrating. Most of you looked at this and decided that's equivalent to x, and it is not x. It is not even remotely close to x. And I'd like to try and convince you of that by just asking you to consider the following. If I looked at 8 plus 2, I think all of you look at that and you immediately say that's 10. Got it? And if I take 10 and I divide it by the number 2, this becomes 10 over 2. It becomes the number 5. Now, with this kind of warped thinking or overgeneralization, right? A lot of you were like literally slashing this out, like, oh, that's gone, that's a giant 1. No, they're not factors in the numerator. That's an 8 plus a 2. It's not 8 times a 2. So we cannot do this, because when you do this, you end up getting that you think that this is the number 8. Well, it's not. It's 5, and 5 is not 8. It refuses to be considered 8. So avoid that. Do not do this. This is not. And I understand. I understand why you're doing it, because, for example, if you did have 8 times 2 over 2, right? The numerator is 16. 16 divided by 2 is 8. So if they are factors of each other, you can create a giant 1 out of common factors. This indicates that these are terms, right? Terms are those things that are added together. They can be positive or negative. Well, you can't cancel common terms. It just clearly does not work, right? So, I'm going to erase this, but think about this, or go back and pause the video and ponder that for a while. So how the heck do you deal with this problem? Well, our big tool that we've been using is fraction busters, and I can do this in 2 steps to make it easier to look at. I can multiply both sides of this equation by 3 first. If I do that, I get 3, and then in my numerator I add an x plus 3, and then over 3. Now, on the other side, I've got 3 times 5 is 15 over 2. Now, when you look at this, what's different is now these 2 3's are common factors. If you look at it, it's 3 times this quantity, x plus 3 over 3. I can eliminate these. That is a giant 1, and that will work just like the 16 over 2 is 8. So what's nice is this left-hand side becomes x plus 3, and the right-hand side is still a fraction, but we can quickly fix that by just choosing to multiply both sides by 2. If I multiply both sides by 2, look at this. This becomes 15 times 2 over 2, which is just the number 15. I do want to caution you. I notice that some of you, would claim that you're multiplying by 2, and then you multiplied both the numerator and denominator by 2. When you do that, you're really multiplying by 1, and we're not doing that. We're setting out to multiply both sides by 2. So if it helps you, right, you're multiplying the denominator times 1 and the numerator times 2. Over on the right hand side, when I distribute this, I have 2x plus 6. So, to simplify, we can take away 6 from each side. We have 2x is equal to a 9, and then I could divide both sides by 2, and x is 9 halves. So, perfectly great answer, 9 halves. And many of you chose to write it as 4.5, and that's fine as well. I do encourage you to think about things as these rational numbers, though. This is a lot cleaner notation. The last problem, the technique that we've discussed in class is this thing called looking inside. And if I magically look inside, I'm grabbing a highlighter. If I look inside of the radical, right, what does that have to be? Well, I know for a fact that the square root of 25 is 5. That's just an arithmetic fact I know. The square root of 25 is the number 5. So I know that the thing inside has to be 25. So if I set this expression inside the radical x plus 12 equal to 25, right? Because I want it to be 25, I can solve this by adding 12 to each side, and I get that x is the number 67. Sure. No, not 67. 37. Not 36. 37. Everyone together, 5 plus 2 is 7, and 2 plus 1 is 3, so it's 37. And again, if I plug the 37 into here, just this is me doing a check. 37 minus 12 is 25, and the square root of 25 is 5. So when I put 37 in for x, it makes the left and the right hand side both equal to 5.